Hello, welcome again. In continuation of part 25, MSV 430 addressing modes. Today we continue and we discuss the symbolic mode, absolute mode, indirect register mode, indirect auto increment mode, immediate mode of addressing modes of MSV 430 microcontroller. Symbolic mode allows the assignment of labels to fixed memory location so that those locations can be addressed. This is useful for the development of embedded programming. Description here is in the index mode, instead of PC, we use R register. But in this case, PC is the register in a symbolic mode of operation. Example, move X PT, Y PT. So XPT, here we use PC. X is nothing but a pointer. Y also a pointer. So move the content of source address XPT, X where X is the pointer, to the destination address YPT, Y is the pointer. Now let's see one small description. The symbolic mode, the source mode bit, always we represent source as AS, destination as AD. For example, add R. It may be 2 or 3 words, valid for both source and destination. Example we already discussed. Here, move the content of source address XPT X pointer to the destination YPT Y pointer. Before execution, XPT is equal to A002H location. YPT is equal to 050AH. After execution, XPT is equal to A002. It is same as this, but content of Y is transferred from the XPT, that is A002H. Now, XPT content is transferred to the YPT. This is what we call as symbolic representation, symbolic mode of operation. Here is the symbolic mode. Assembler code for this: move EDE, TONI, move X of PC, Y of PC. X is equal to EDE, that is source address minus PC, Y TONI minus PC. Length 2 or 3 words. Operation: move the content of source address EDE, content of PC plus X, content of PC plus X to the destination address TONI, content of PC plus Y. The word after the instruction contains the difference between the PC and the source or destination addresses. Here you can see this. Here, X is equal to ED E minus PC, Y is equal to TONI minus PC. The assembler computes and insert the offset X, Y automatically with symbolic mode. The PC program counter is incremented automatically so that program execution continues with the next instruction. So this is source EDE, TONI is the destination. The source EDE is the value address and destination address is TONI is equal to 01114H. First you take this 0FF14 0FF14 plus this value, it may be the X, you add, you will get 0F16H, the data is here. Another value that is 0F16H, we are taking these two with the content that is 011FEH. You will get destination address. Destination address is here. So the content of 0F016, that is from here to, it is moved to 01114H. The content is available here. Next goes to absolute mode. It is similar to symbolic mode with the difference that the label is preceded by %. The word following the instruction containing the absolute address. X is stored in next word, indexed mode, X of SR is used. Move %. Here is the %. We can specify the label. Label is this one. With a symbol, % symbol, so that content of memory location whose address is specified by this label will transfer to the memory location whose address is specified by the label. Here, from one label to other label, move the content of source address XPT to the destination address YPT. Absolute address, move %. Here is we use for absolute mode, we use % with a label. This is the label. This is the label with a % symbol. X is equal to EDE, Y is equal to TONI. There is no specific meaning for EDE or TONI in MSP 430 microcontroller. The length is 2 or 3 words operation. Move the content of source address. This is just a source address. It is a label to the destination address. Another label TONI. The word after the instruction contains the absolute address of the source and destination addresses. With absolute mode, the PC is incremented automatically so that program execution continues with the next instruction. Valid for both source and destination. Example here is move ampersand EDE, ampersand TONI. Source address, we assume this. This address is 0F016H. Destination address is TONI is equal to 01114H. Which address it is? 0F016. 0F16. Here. The content 0F016H contains 0A123H. It will be move on to this label, that is TONI is equal to 01114H. It will be here 01114H. The content is now available after execution of this instruction. It will be there in memory location 01114H, that is 0A123H. From here to this memory location. Next we will move on to indirect register mode. Indirect register mode, we use move at symbol R4, R5. At symbol is there. The data word address is located in memory location pointed by Rn. This is a address. Indirect mode is not valid for destination operand, but can be emulated with indexed mode format. At bracket, within bracket Rn, here Rn is used as a pointer to the operand. Move the content of source address. Content of source address. This is the at symbol is used for address to the destination register R5. Register R4 is not modified. Move at symbol at the rate symbol R10, 0 of R11. Length 1 or 2 word. Move the content of source address, content of R10 to the destination address, content of R11. The registers are not modified. Valid only for source address. The substitute for destination operand 0 of RD. Now we'll take example. Move dot B. If you put the parenthesis on both sides of B dot B, then it would be word. If it is open, then it would be byte. At the rate R10, 0 of R11. Before address space is R10 is holding 0FA33H. 0FA33H. R11 holding 002A7H. After execution, R10 holding, this is a 0FA33. R11 holding the content 002A7H. After execution, R10 is equal to 0F33H, or 11 is equal to 00A7H. Next goes to indirect auto increment mode. It is like indirect addressing mode. Similarly to indirect addressing mode, but with indirect auto increment mode, the operand is incremented as a part of the instruction. The format for the operand is @RN plus. This is useful for working block of data. Rn is used as a pointer to the operand. Rn is incremented afterwards by 1 for byte instruction and by 2 for word instruction. So this will be helpful for moving blocks of data. Move the example, move at the rate R4 plus, comma, R5. Move the content of source address R4 to the destination address R5. Then increment the value in the register R4 to point to the next word. Indirect auto increment move. The symbol or instruction we use is move at the rate R10 plus. This is the plus. For the byte, it is incremented by 1. For word, it will be incremented by 2 after the execution of this instruction. 0 of R11, 1 or 2 word operation. Move the content of source address, content of R10 to the destination address, content of R11. Register R10 is incremented by 1 for byte operation or 2 for word operation after the fetch. It points to the next address without any overhead. This is useful for table processing. Comment valid only for source operand. The substitute for a destination operand is 0 of RD plus second instruction INCD RD. Okay. Move at the rate R10 plus, comma, 0 of R11. R10 is holding this value, R11 is holding this value. After executed this instruction, R10 is incremented by 2. R10 is incremented by 2. So R11 is not affected. Immediate mode not different from direct addressing mode. In immediate mode, address is available as the part of the instruction itself. Immediate mode is used to assign constant value to the registers or memory locations. Here is the hash. E2 is the constant. So move the immediate constant E2H to the destination register R5. This is the meaning of immediate mode. Here you can see immediate mode description. Assembler code is move hash 45H to, comma, destination is ONI. 2 or 3 word. It is the word less if a constant of CG1 or CG2 can be used. Move the immediate constant 45H, which is contained in word following the instruction, to destination address TONI. When fetching the source, the program counter points to the word following the instruction and move the content to the destination, valid only for source operand. Okay, now we will see move hash symbol 45H, comma, TONI. Before execution, zero FF16 0 FF16H. This is the one. Add with this value 01192. You will get 011A 8H. A8H. This is the immediate value. We move to the destination address.